Dear student, today I will discuss about parallel decomposition of a system. I already discussed about the basic thing of the decomposition techniques. So for the parallel decomposition technique, we just start with an example. For that, let ys by us is a transfer function of a system, and that is equal to a square plus 6s plus 8 that divided by s cube plus 5s square plus 8s plus 6. And if we factorize this thing, then we can get a square plus 6s plus 8 divided by, in the denominator part, s plus 3 into s square plus 2s plus 2. If we go for the partial fraction, then we can write a divided by s plus 3 plus b into s plus c divided by s square plus 2s plus 2. So we can say that these things should be equal with the transfer function which is given to us. So we can write s square plus 6s plus 8 divided by s plus 3 into s square plus 2s plus 2, that should be equal with a divided by s plus 3 plus b into s plus c divided by s square plus 2s plus 2. So if we take the LCM of the system, then we can get s square plus 6s plus 8 is equal to a into s square plus 2s plus 2 plus b into s plus c into s plus 3. So we can write s square plus 6s plus 8 is equal to a plus b into s square plus 2a plus 3b plus c into s plus 2a plus 3c. Now if I compare the coefficient of s squared from both sides, then we can write a plus b is equal to a. If we compare the coefficient of s from both sides, then we can write 2a plus 3b plus 6. And if we compare the constant terms from the both sides, then we can say 2a plus 3c, that is equals to 8. So from the equation 3, that means 2a plus 3c is equal to 8, we can find out the value of c, that is 3c is equal to 8 minus 2a, and from that we can get c is equal to 8 minus 2a divided by 3. Now if we put the value of c in the equation 2, that is 2 into a plus 3b plus c is equal to 6, then we will get a equation which just consists with only a and b term, that is we will get finally 4a plus 9b is equal to 10. So this is equation 4. So we can use the elimination process to solve the two equations, and we have to find out the value of a and b. For that purpose we just take equation 1 and equation 4. So the equation 1 is basically a plus b is equal to 1. So for the elimination process we just multiply the equation 1 with 4. So now the equation will become 4a plus 4b is equal to 4, and the another equation is 4a plus 9b is equal to 10. If we subtract these two equations, then we will get minus 5b is equal to minus 6. That means 4a will be cancelled out. So from this equation we can find out the value of b, which is 6 by 5. And if we put the value of b in the equation 1, then we can find out that a is equal to minus 1 by 5. And if we put the value of a and as well as b, and we can get the value of c, that is 14 by 5. So we will get the three coefficient a, b and c. Now we put this value in the transfer functions ys by us. So now the transfer function will become ys by us is equal to minus 1 divided by 5 into s plus 3 plus 6 by 5s plus 14 by 5 divided by s square plus 2s plus 2. If we rearrange this thing, then it will become 6s plus 14 divided by 5 into s square plus 2s plus 2 minus 1 divided by 5 into s plus 3. So we can say that this is a term, or this is a factor, and this is another factor. this factor we assume as y1s by us, and we assume this factor as y2s by us. Now for the first case, that is for y1s by us is equal to 6s plus 14 divided by 5s square plus 10s plus 10. If we take the cross multiplication, then we can write the equation 5 into s square into y1s plus 10 into s into y1s plus 10 into y1s, which is equals to 6s us plus 14 into us. Now if we take the inverse Laplace on the both side, then we can write 5 into d2 y1t dt2 plus 10 dy1t dt plus 10 y1t, that is equals to 6 into dut dt plus 14 ut. Now assume that y1t is equal to x1 is a state. Then if we take the first differentiation on y1t, then it will be y1 dot t is equal to x1 dot is equal to x2. Now if we take the second differentiation, then y1 double dot t, that is equals to x1 double dot is equal to x2 dot. Now if we take the equation x1 dot, that is x1 dot equals to x2, so we can write this equation x1 dot equals to 0 into x1 plus 1 into x2 plus 0 into u dot plus 0 into u, and the another equation x2 dot equals to minus 2x1 minus 2x2 plus 6 by 5 into u dot plus 14 by 5 into u. So from these two equation we can write a single matrix form, that is x1 dot x2 dot is equal to a square matrix 0 1 minus 2 x into x1 x2 plus 0 0 6 by 5 14 by 5 into u dot u. So the final equation is just equal with the x dot is equal to ax plus bu. So we can say this is the state equation of the following transfer function. So we already get the state equation of the system. Now we have to find out the output equation of the system, which is very essential. For that we just take another term, that is y2s by us is equal to minus 1 divided by 5s plus 15. If we take the cross multiplication of this equation, then we can write 5 into s into y2s plus 15 into y2s, that is equals to minus of u into s. Now if I take the inverse Laplace on both sides, then we can write 5 into dy2 dt plus 15 y2t is equal to minus ut. If we assume y2t is equal to x3, then y2 dot t is equal to x3 dot. So if we put these values in the equation, then we will get 5 into x3 dot plus 15 x3 is equal to minus ut. So x3 dot is equal to minus 3 into x3 minus 1 by 5 into ut. Output equation we know that yt is equal to y1t plus y2t, which we already get from the parallel decomposition method.